pressure the pressure exerted by a gas molecule exerted by a gas molecule is inversely proportional to is inversely proportional to its volume occupied by gas. Okay. Now see here, this is the statement of Boyle's law. At a constant temperature, the pressure exerted by a gas molecule is inversely proportional to its volume. Okay. So therefore we can write P is inversely proportional to V. So P is the pressure, V is the volume. When pressure is inversely proportional to its volume, when temperature remains constant, when temperature is constant. Okay. Therefore we can write PV is equal to constant. PV is equal to constant. Okay. Now see here, where P is the pressure, P is the pressure of an enclosed glass, Okay. Similarly, V is the volume. V is the volume of an enclosed gas. Okay. P is the pressure of an enclosed gas. V is the volume of an enclosed gas. Now this Boyle's law can be derived on the basis of kinetic theory of gases. This Boyle's law can be derived on the basis of kinetic theory of gases. Okay. Now let us consider. V is the volume of gas, N is the number of molecule, Okay. And small n be the mass, of each molecule, Okay. So capital M be the total mass of a gas, that is equal to N into M. So it is the total mass of gas. Okay. Now in previous lecture we had already derived the formula for pressure. So we know that P pressure is equal to 1/3 rho into C RMS square. Okay. C RMS square. Okay. So we know that density is equal to mass upon volume. Substituting in this equation, we get pressure is equal to 1/3 into mass upon by N into M. So we get PV is equal to 1 by 3 into M is replaced by N into C RMS square. Okay, where N is the number of molecules, M is the mass of each molecule. Okay, now so therefore PV is equal to 1 by 3 into N into M into C RMS square. Okay, so multiplying we can adjust this term. So C here or C here PV is equal to, this can be written as 2 by 3 into 1 by 2 into N into M into C RMS square. So see here, 2 get cancel. So 1 by 3 into N M into C RMS square. So we get this term again. Okay. So see here, PV is equal to 2 by 3 into N. We can arrange this term as like 2 by 3 into N into 1 by 2 into M into C RMS square. 1 by 2 into C RMS square. Okay. Now see here, half M V square. So this is the formula for kinetic energy. Okay. Now see here, N is the number of molecules. Okay. So number of molecules, this term is constant. The quantity half M into C RMS square is the average kinetic energy. Is the average kinetic energy of a gas molecule. It is also constant. Now see here, N is the number of molecule. So it is constant. Okay. So half M into C RMS square. This is the average kinetic energy. Average kinetic energy of a gas molecule. Of a gas molecule which is also constant. So therefore PV is equal to constant. PV is equal to constant. Okay. So see here, the average kinetic energy of a gas molecule is constant at constant temperature. So PV is equal to constant. Therefore we can write P is inversely proportional to volume. Hence Boyle's law is direct. Okay. See here, the statement of Boyle's law: at a constant temperature, the pressure exerted by a gas molecule is inversely proportional to its volume occupied by the gas. Okay. So from this statement we can write P is inversely proportional to V when at a constant temperature. So PV is equal to constant. So where P is the pressure of an enclosed gas. P is the pressure of an enclosed gas. V is the volume of an enclosed gas. Okay. Now, so let us consider V is the volume of gas, N is the number of molecules, small m be the mass of each molecule, capital M be the total mass of a gas, that is M is equal to N into M. So by using the formula of pressure, okay, for the deriving the Boyle's law, we are using kinetic total mass of a gas can be substituted by n into n, or capital M is replaced by n into m. So we get PV is equal to 1 by 3 into Nm into CRM square. Okay, so we can rearrange this term. Okay, so 2 by 3 to 1 by 2 to get cancel. So again we get 1 by 3 into n into m into CRM square. This term can be again rearranged by 2 by 3 into n into half m CRM square. So half m CRM square means half m CRMS square. Okay, so half mv square is the kinetic energy. Therefore, see here, n, capital N is the number of molecules, which is also constant. Okay, and half m CRMS square is the average kinetic energy of a gas molecules. Okay, which is constant at constant temperature. Therefore, PV is equal to constant, since P is inversely proportional to 1. Okay, this is the Boyle's law. Now, next point, to find the relation between CRMS velocity and temperature. To find the relation between CRMS velocity and temperature. Okay. Now here let us consider 1 mole of ideal gas. 1 mole of ideal gas. 1 mole of ideal gas enclosed 1 mole of ideal gas enclosed in a volume V with pressure P at temperature T. Okay, at temperature T. Now see here, let us consider a 1 mole of gas which is enclosed in a volume V with pressure P and at temperature T. Okay, so we know that the formula for pressure, so P is equal to 1 by 3 into rho into CRMS square. Therefore, substituting the formula for density, so we get, therefore P is equal to 1 by 3 into m upon V into CRMS square. Okay, therefore PV is equal to 1 by 3 m into CRMS square. Okay, so 1 by 3 into CRMS square. Now see, for an ideal gas, for 1 mole, for ideal gas, for 1 mole, that is n is equal to 1. So we know that ideal gas equation. So ideal gas, so this is equation number 1. So ideal gas equation, we know that PV is equal to nRT. PV is equal to nRT. So we get n is equal to 1 for 1 mole of gas. So we get, therefore PV is equal to RT. Calling the equation number 2. Now see here, PV is equal to RT. So PV is RT, or from equation 1 and 2 we get PV is equal to RT. Therefore RT is equal to 1 by 3 m into C 1 by 3 RT. Sorry, RT is equal to 1 by 3 into m into C RMS square. Okay. Now we want to find the C RMS. So we get C RMS square is equal to 3 RT upon m, 3 RT upon m. Therefore taking square root on both sides. Taking square root on both sides. Therefore C RMS is equal to under root 3 RT upon m. Okay. Now see here, 3 is the number, so 3 is constant. R universal gas constant. M total mass of a gas, it also constant. So therefore see here, where R is the universal gas constant. Okay. M is the total mass. M is the total mass of gas. M is the total mass of a gas. So this also constant. Therefore we can write C RMS is directly proportional to root T. C RMS is directly proportional to root T. This is the relation between C RMS velocity and temperature. Okay. Now see here, I can repeat again. To find the relation between C RMS velocity and temperature. Okay. So consider 1 mole of an ideal gas. Okay. Enclosed in a volume V with pressure P at temperature T. Okay. So we know that the formula for pressure P is equal to 1 by 3 into rho into C RMS square. By substituting the formula of density is equal to mass upon volume. So we get this equation. So PV is equal to 1 by 3 into m into C RMS square. Okay. Now for ideal gas, 1 mole for 1 mole. So that is n is equal to 1. So we know that the ideal gas equation PV is equal to nRT. So n is equal to 1. Therefore PV is equal to RT. So substituting or replacing PV by RT. So we get RT is equal to 1 by 3 m C RMS square. So we want to find the value of C RMS square. So C RMS square is equal to 3 RT upon m. So we get taking square root on both sides. So C RMS is equal to under root 3 RT upon m. 4. Now see, in this equation 3 is the number, so it is also constant. R is the universal gas constant and capital M being the total mass of a gas. Okay, this is also constant. Therefore the C RMS velocity is directly proportional to square root of temperature. Okay. Okay. Now we are finding the value of kinetic energy of gas. Okay. So we know that the formula for pressure P is equal to 1 by 3 into rho into C RMS square. So therefore P is equal to 1 by therefore this 3 is going toward this, so 3PV is equal to M2CRMS square. So we know that the general formula for kinetic energy is equal to half mv square. Now see here m into CRMS square. Okay, so arrange this half, so we get multiply on both sides, multiply on both sides by 1/2. So we get therefore 3/2 into PV is equal to half mCRMS square. Okay, that means the kinetic energy of gas. Therefore, the kinetic energy of gas is equal to 3/2 into V. This is the kinetic energy of a gas. Okay. Now next we are writing second point. Kinetic energy per unit volume. Kinetic energy per unit volume. Okay. Now see here, we finding the next term, that is kinetic energy per unit volume. So the formula for kinetic energy per unit volume, that is kinetic energy of gas divided by volume of the gas divided by volume of gas. Therefore, substituting the value of kinetic energy is equal to 3/2 into PV divided by volume of the gas P. So V get cancelled, therefore which is equal to 3/2 P. Okay, therefore the kinetic energy per unit volume of gas is equal to 3/2 into P. Okay, this is the second formula. Okay, now next one, that is kinetic energy per mole. Next one, that is kinetic energy per mole. Okay, kinetic energy per mole. So we know that the ideal gas equation, okay, for ideal gas, we know that PV is equal to nRT. PV is equal to nRT. Okay. Now the kinetic energy of a gas is equal to, now therefore the kinetic energy of gas is equal to 3/2 into PV. 3/2 into PV. Okay. Now for ideal gas, the kinetic energy per mole. Okay. Now see here, this value of P is substituted in this equation. So we get kinetic energy of gas is equal to 3/2 into nRT. 3/2 nRT. Okay. Now see here, 3/2 is a number, so it is also constant. N is the number of moles, it also constant. R universal gas constant. Therefore, from this we can write kinetic energy is directly proportional to T. Kinetic energy is directly proportional to T. Okay. Now to find, so for 1 mole of to 3 by 2 PV or 3 by 2 RT. It is kinetic energy of gas per mole, which is equal to 3 by 2 PV, 3 by 2 PV, okay, or which is equal to 3 by 2 RT, which is equal to 3 by 2 RT. Substituting here, n is equal to 1, so we get 3 by 2 RT. Okay, this is the kinetic energy of a gas. This is the kinetic energy of a gas per mole. Okay, now see here I can revise again to find the kinetic energy of gas. So we know that the formula for pressure P is equal to 1 by 3 into rho into CRMS square. Okay, by substituting the formula for density is equal to mass upon volume. Okay, so P is equal to 1 by 3 m upon V into CRMS square. Therefore PV is equal to 1 by 3 m into CRMS square. Okay, so 3 PV is equal to m CRMS square. So multiplying on both sides by half, so we get kinetic energy of gas is equal to 3 by 2 PV. Okay, next one, that is kinetic energy per unit volume. So to find the kinetic energy per unit volume, so divide kinetic energy of a gas by volume of a gas, so we get 3 by 2 P. Okay, and next one, kinetic energy per mole. For ideal gas equation, PV is equal to energy. So we find the kinetic energy per mole, that is n is equal to 1. Okay, so kinetic energy is equal to kinetic energy of a gas is equal to 3 by 2 PV is equal to 3 by 2 nRT. Okay, therefore 3 by 2, that is the number. Okay, and n is the number of moles, R universal gas constant. Therefore from this we can write kinetic energy is directly proportional to T. That means kinetic energy depends upon temperature. Okay, for 1 mole n is equal to 1, so PV is equal to RT. Therefore kinetic energy of a gas per mole, which is equal to 3 by 2 PV or 3 by 2 RT. Okay, next one, that is kinetic energy per molecule. Okay, so kinetic energy per molecule is calculated by, how we calculate the kinetic energy per molecule? So the kinetic energy of gas per mole divided by kinetic energy of a gas per mole divided by Avogadro's number. So we know that the kinetic energy of a gas per mole, that is 3 by 2 RT, 3 by 2 RT divided by Avogadro's number Na. So this is equal to 3RT upon 2 into Na. Okay, so we know that R universal gas constant. Okay, so we know that derivation, since R is equal to Na into Kb, where Kb is the Boltzmann constant. So we can write Kb, that is Boltzmann constant, is equal to R upon Nb. Okay, so substituting in this equation, so we get the kinetic K, it is Boltzmann constant, into temperature. This is the kinetic energy of a gas per mole. Okay. Now next one, that is kinetic energy per unit mass. Kinetic energy per unit mass. Okay, this kinetic energy per unit mass can be calculated by the formula kinetic energy per mole divided by molecular weight. It is calculated by kinetic energy of gas per mole divided by molecular weight. So, kinetic energy of the gas per mole, that is 3 by 2 RT upon molecular weight m. So, which is equal to 3 RT upon 2m. This is the kinetic energy of a gas per unit mass. Okay, so these are the formulas. Okay, thank you.